Welcome to BTEC Revision. In today's lesson, we're looking at kinetic energy. By the end, we should be able to calculate the kinetic energy of objects. Kinetic energy is the energy any object has when it is moving. And we can calculate kinetic energy using this equation. Kinetic energy equals half times mass times velocity squared. So you can see here, if we double the mass, the kinetic energy is going to double. So let's say we have a cyclist, and this cyclist has a mass of 100 kilograms. So let's say his kinetic energy is 10,000 joules. And if, let's say, he's holding some object to increase his mass up to 200 kilograms, then his kinetic energy is going to double to 20,000. If you double the velocity, the kinetic energy is going to double squared, so increase by 4 times. If we triple velocity, okay, so if velocity goes up 3 times, then the kinetic energy is going to 3 squared, so that's 9 times it's going to increase. The units is joules for kinetic energy, and we can use kilograms for mass, and velocity is measured in meters per second. Let's look at an example. A ball with a mass of 500 grams is thrown vertically upward with an initial velocity of 15 meters per second. What is the kinetic energy of the ball just after it is thrown? Kinetic energy is equal to half mv squared. So we can plug in our values. 1/2 times mass, which is 500 grams. So we will need to convert that to kilograms. So that would be divided by 1,000 for kilograms. So that's 0.500 kilograms. So that's times by 0.5 and multiply that with 15 squared. Which would give us a value of 56.25 joules. Now pause the video here and attempt this exam question. Let's start by drawing a quick sketch of the car moving along with the velocity v. So this is going to have kinetic energy. And when this car is moving along under braking, it's going to slow down. So this energy is being transferred into friction because there is friction between the surface of the road and the tires. So this energy, kinetic energy, is being transferred into thermal energy. And when the car is completely stopped, all of that kinetic energy has been transferred. So initially, the energy is kinetic energy, and then after, it's all thermal energy. So work has been done. So what we can do is we can use the work done because we know initially it was kinetic energy. So 100,000 joules is our kinetic energy. Now we can start by writing down the equation. Kinetic energy is 1/2 mv squared. Next, you can see the question is asking for the velocity. So that means we will need to rearrange this equation. So what we will have to do is multiply both sides by 2 to give us 2 kinetic energy equals mass times velocity squared. That's how we will get the half over to the other side, because if we multiply 2 here, that gives us 2 divided by 2, which cancels out. And that means we will have to times the left side by 2 to make it mathematically balanced. Next, we can see we want to move over the mass. So we divide both sides by mass. The masses cancel out. So we're left with 2 kinetic energy over mass equals velocity squared. Now, how do we get velocity on its own? We can see it's velocity squared. So we'll have to square root that. And therefore, we'll have to square root the other side. So that would give us square root of 2 kinetic energy over mass equals velocity. And now we can just plug in our values. So we've got velocity equals square root of 2 times kinetic energy, which is 100,000, divided by the mass. And if you look here, another unit we need to know is a ton. 1 ton is 1,000 kilograms. So kilograms is the correct unit. So we can divide by 1,000. And this would give us a value of 14.14 meters per second. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions at btechrevision.com. See you next lesson.